So with that, let's move on. This is talking about how did we, come up to the industrial revolutions. Starting with 1784, where there was no industry. Essentially, steam power just showed up, and that steam power revolutionized quite a few things, including railroad. Before that, the industry was intensely local. If you produced at one place, it has to be consumed at the same place. There was no transportation per se for longer distances. Steam power changed that, and that was called Industry 1.0. And then came the era of Industry 2.0, essentially mass production of assembly lines and electric energy. And machine learning is kind of touted as electrical energy, and in the sense that by itself it's not much of a technology because it doesn't do much by identifying a person or looking at vibrations. The applications thereof are very powerful, and I'll give you examples similar to electrical energy. For example, there is not much you can do by moving an electron from one place to another, right? And that's all there is in the current, right? And in electric power. But when you provide electric power to the entire planet, the applications starting from electric bulb to the hundreds of appliances that are very popular in the households and the buildings today that you cannot imagine your life without. Essentially, the way you live your life changes quietly because of those innovations. And electrical energy in late 1800s was one of those. And then came semiconductor era. So with the semiconductor in 1970s, you started seeing these little tiny chips that started bringing automation to the industry, and smart bells and little tiny robots that are building cars today. They've been building it for almost 30 to 35 years, and the automation continues to make us efficient. And that was Industry 3.0. And the 4.0 essentially is IoT, TinyML, and cyber physical systems, where the senses that humans have, like we have our eyes that we see with, and there are cameras like the one you see in my hand. It's a tiny Arduino cam, and it's a very tiny chip, and you can capture reasonably sized video on this with limited latency, and can run some of the applications. And the deep learning part, which is AI vision, today, actually not today, going back 8 years, has outperformed human vision. So the machine learning or deep learning does a better job of identifying an object as that object versus a human would do. So we are verifiably inferior when it comes to our senses, especially our audio and vision senses. So that is the sense of industrial revolutions and as to where we are in 2022. And how this went about in creating some of these infrastructures, essentially water, steam, mechanical production, electricity and mass production, and robotics and such. Internet of Things essentially combines a lot of these applications industries into smaller verticals that creates these efficiencies on automation in each areas of our lives and factories and jobs and daily routines. And one thing that each one of these little tiny boards have in common is they are connected to internet. And what we're going to talk about today is the IoT has been there for almost 8 to 10 years, and there are several applications. The next wave is coming where you don't have to connect. The connectivity is optional. What that means is you can run the entire AI application on this board, which you are carrying around in your pocket, running on a AA battery or a point cell battery, and it's not even connected to internet. You can go in the space, you can go in the shipping, mining, smart farming. There are a lot of industries where the access to electricity or internet can be luxury. So we are sort of touching and completing that reach of these smart AIoT things to 100%. Now, there is one thing I would like to clarify here. IoT versus AIoT, there is a minor difference. IoT is Internet of Things, and when I say AIoT is artificial intelligent of things, meaning it's not internet, it's artificial intelligence of things. Internet in AIoT is optional. You can connect, you can add internet or GPRS module on top, and that is optional. So IoT and AIoT seem similar, they are not. And you might have heard or you will hear about this taxonomy where it goes like AI is a large field, machine learning is part of it, and deep learning is part of machine learning, and neural networks is even a smaller part. Now, where does TinyML fit? TinyML essentially is the intersection of machine learning, deep learning, and neural networks, somewhere here. And the differentiation of that is, when we are looking at the small power, small boards that may or may not be connected to internet, is essentially your TinyML. And some of the taxonomies that I'm going to talk in this forum, in this talk, is network. When I say network, it could be cloud, it could be edge. Edge devices are something you carry around on a daily basis, like a cell phone, which is an edge device because that device is not sending the data further. It's basically the data gets consumed on your device and goes back. So that's an edge of the network, if you would. Cloud is essentially server where things get processed. ML, when I say model, I'm talking about a model in the context of machine learning. Training meaning we are training a model. Inference meaning the model is trained and we are using that model. And hardware, IoT or MCU. IoT is essentially your Internet of Things. MCU is microcontrollers. And the benefit of TinyML that I'm going to talk about in the next few slides is low power, low latency, and security.